Okay, this is kind of neat. I like the little drawing. Uh, they're telling us, we're looking at the patterns. They're saying make a table and draw a graph to show the relationship between the number of houses and the number of windows. And they're telling us down here, use n for the number of houses and k for the number of windows. So let's now start to fill out this table a little bit. Okay, if n is the number of houses, then there where we see that first house up here, how many windows are there? There are 4. Yep. And what about if there were 2 houses like here? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 windows in 2 houses. 2 houses means 8 windows. And likewise, over here, we have 1, 2, 3 houses. So how many windows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Makes sense because there's 4 for each one. So we end up taking the number of houses and multiplying it by 4 to find out the number of windows. Yeah? Okay. So it says, what is the number of windows in 9 houses? Well, we could make a list all the way down. We could say 4 means this many windows, 5 means this many. But the fact is, we don't actually really need to know all of the amounts in between. They would just want to know 9. So let's do a better job and let's relate the two variables together. Okay? Let's relate the variables together, and we can say the number of houses, n. Remember, that's a smaller number than the number of windows. There's a lot more windows than there are houses, right? Because there's multiple windows per house. So take the number of houses, and we're going to, let's see, what do we do with this to get to here? Multiply it by 4. What do we do with this to get to here? Multiply it by 4. What do we do with this to get it to here? Multiply by 4. Take n, multiply it by 4, and that will be equal to k, the number of windows. That's the equation, okay? Because in A it says what is the number of windows in 9 houses? Well, now we can just say, well, k is equal to 4 times, there's 9 houses, so we're going to substitute in 9 for it. And what do we get? Equals 36. For 9 houses, there's 36 windows. What is the total number of windows in 9 houses? 36 windows. Okay? And then going back to this original equation, I'm going to take this out now that we've used it, and I'm just going to keep the original equation just for the sake of space. If n houses has k windows, right? N houses has k windows, then write an expression to represent the number of windows for n plus 1. Well, now let's put in here, we can say what's going to be if we put here, instead of n, we put n plus 1. Okay? Well, it makes sense that what we're going to get as a result is going to be, well, let's do it. 4 times n, 4n. 4 times 1, 4. The distributive property. Okay? And we say, well then, an expression to represent n plus 1 houses would be 4n plus 4 windows. Okay, k for that many, for n plus 1 houses is that many 4n plus 4 windows. Because remember, you multiply the number of houses by 4, so that's that. But then if we add one more house on, we'd end up adding 4 more windows. So this expression, 4n plus 4, is what the answer is. Here's, if you have n houses, 4 times n will be the number of windows. If we added another house on, we have to add another 4 windows. That expression is what we're looking for. They also said to graph it. Okay, make a table and draw a graph. So I'm going to go down here and we're going to graph it. That's going to be the last thing that we do. And we say, okay, this is the number of houses. And we say 1, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. Right? Okay, but over here, because we're going by, we're increasing by 4 times as much, I'm actually going to make this scale 4, because why not? Okay, 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40, even though you can't see it. 40 would be up there if we extended the graph. Okay, so now let's plot it. Again, remember, we've got a different scale on the y-axis, so it's not going to jump up 4 units higher for every 1 unit that we go over. Since the scale has changed, it's going to look a little different. But let's plot them. Okay, we say, well, 0 houses would have 0 windows. That's obvious. 1 house would have 4, and I've made these marks each 4. 2 houses would have 8. 3 houses would have 12. And if I kept going, we could say 4 houses has 16. 5 houses has 20. 10 houses has 40, etc. And so let's plot those and see what we get. We've got 4 has 16. 5 houses has 20. That works because there's 5, there's 20, and they're all in a line. And finally, going over here all the way to 10. If we had 10 houses, we would go up to 40 right there. And that we know works because if it works right, they should all be falling in a line. And as you can see, they are all falling in a line. So we know that we've done it correctly. Okay? Even though, again, we technically can't connect them because we don't have parts of a house and parts of windows or nonsense like that. These make jumps from either 0 houses or 1 or 2 or 3 or 4. And we call that discrete versus continuous. It's not a smooth continuous line where every value in between works too. It's just discrete jumps of could be this, or it could be this, or it could be this, or it could be this, but not everything in between. Okay? We'll focus more on that in the future.